Good morning, sir.
गुड मॉर्निंग अनिल जी।
Yes, sir.
अभी शेयर कंटेंट नहीं खुला है ना?
नहीं सर, वो जब आपका प्रेजेंटेशन का होगा तो आपको मिल जाएगा।
अच्छा,
अभी नहीं है।
ओके, दैट्स
जी,
फाइन,
sir.
दैट्स फाइन।
A very good morning to all the panelists and the participants. On behalf of National Institute of Disaster Management, Ministry of Home Affairs, and Institute of Petroleum Safety, Health, Environment Management, ONGC Goa, I welcome you all to the second day of 3-day online training program on disaster risk reduction in hydrocarbon sector. The first day of the training program was commenced with the inaugural address from Mr. Arun Mittal, Executive Director, Oil Industry Safety Directorate, Ministry of Petroleum and Natural Gas. His address, he shared his vast experience about the hydrocarbon sector. And in technical session, three speakers, namely Dr. Harjeet Kaur, Mr. Raju Thapa, and myself, provide insight on the national and international guidelines frameworks for the disaster management. Request Sri Alok Kumar, Manager Fire Services, IPSEM ONGC Goa, to kindly welcome our distinguished speakers and the participants. Over to you, sir.
Yeah, thank you, Mr. Nidin. Am I audible?
Yes, sir, you are audible.
Okay, thank you so much. Respected Shri VP Mahavar sir, ex-director onshore ONGC, Shri Hirak Dutta sir, ex-ED OSD, Shri NN Ray sir, CGM Head Training IPSHAM, and team from NIDM and wonderful participants. A very good morning to all of you. I, Alok Kumar, Manager Fire Services from IPSHAM Goa, welcome you all on the second day of our 3 days online training program. I am thankful to all the distinguished speakers for accepting our request and gracing this online training program. I believe that we will all be highly benefited with this training program, and we will incorporate all the learnings what we will receive from this 3 days program. This I hand over the mic to Sri Anilji. Thank you.
Thank you very much, sir, for welcoming our distinguished speakers and the participants. So coming back to the today's technical session. In today's technical session, distinguished speakers, namely Shri Hirak Dutta, ex-IOC, former ED, OISD, Ministry of Petroleum and Natural Gas, and former advisor and head safety, Nayara Energy, Shri VP Mahavar, former director, ONGC, and Shri NN Ray, Chief General Manager, Head Training, IPSA, ONGC Goa, will be joining us to enlighten us on various phases of disaster risk reduction, especially in hydrocarbon sector. I request participants for their active participation in the technical session through their queries, which they can share via question Q&A box. And after each presentation, we will be taking your queries to the respective panelists. Now, I invite today's first distinguished speaker, Shri Hirak Dutta. He is ex-IOC, former Executive Director, OISD, Ministry of Petroleum and Natural Gas, and former advisor and safety head, Nayara Energy. Sir will be enlightening on the response and preparedness in hydrocarbon sector. Over to you, sir.
Thank you, Anil Kathaji. Enable the share. Okay, fine. Yeah, thank you, Anilji, and thanks to ONGC for organizing this, for having this program with NIDM. It's a great pleasure to be here this morning. And first, I must say that NIDM is doing a fantastic job by taking a pivotal role in organizing such type of programs, which I'm sure will help the benefit, and also ONGC for agreeing to conduct this program along with NIDM. My presentation, as Anil Kathaji has said, I will talk about disaster risk reduction, response, and preparedness. For how do you respond, and what would be your preparedness to reduce the disaster risk? This is my, in short, the agenda for today's presentation. I will give a little prelude to disaster reduction. How do you reduce a disaster? Then we'll talk about risk and accident reduction approach. I will share with you a model through which we can reduce the risk. One cannot eliminate the risk. There will always be some risk. We cannot bring the risk to zero level. Risk can be brought down to as low as practicable level. So that we'll talk about it, risk and accident reduction approach, a model. Then we'll talk about a case study on a major catastrophic incident which happened in our own oil and gas industry. What went wrong? We'll talk about performance improvement cycle. How do we improve the performance? And finally, I will give you a little bit about, talk about a high reliability organization, as to how a high reliability organization, what are the features of a high reliability organization, and how does a high reliability organization reduce the risk of disaster. So that is my this presentation. First of all, when you come talk about this disaster risk reduction is a systematic approach. It's a systematic approach of identifying, assessing, and reducing the risk. So most important thing for when you talk about the risk and hazard is to identify. When you talk about hazard identification, so identify what are the risks, identify what are the hazards, then we assess the risks. And then once, if you don't know what are the risks, if you don't identify the risk, and if you don't identify the hazards, if you don't assess the risks, if we don't assess the hazards, we will be unable to reduce the risk. So first step for disaster reduction, it's a systematic approach of identifying, assessing, and reducing the risks. And it aims to reduce socio-economic vulnerabilities. That's very, very important. And other hazards that triggers them. So this is important. Oil and gas industry, my friends, we are all from oil and gas industry, and as you all know, it's a highly hazardous industry. We handle highly flammable petroleum products. ONGC in the upstream sector. ONGC also has a presence in the downstream sector. ONGC has a refinery at Mangalore. So we handle highly flammable petroleum products, and the refineries and the petrochemical complexes operate at high temperature and high pressure. Even if you talk about the oil exploration, if you go into the deep sea, it's a high pressure, high temperature oil exploration business. Along with that, one of the important things for the oil and gas industry, if you talk about the Mumbai High was discovered in 1975. So many of the oil and gas industry assets are old and aging. So if an asset is old and aging, it poses a challenge to the entire organization. So it requires special attention to avoid major catastrophic incidents. Since oil and gas industry assets are old and aging, you have your own asset, which is Mumbai North, Mumbai High, which is now more than 50 years in operation. So these assets, and for example, many pipelines in our country, they are more than 70 years are in operation. So this, in fact, in refinery, the Rigboy refinery of IOC is more than 100 years in operation. So these assets are old and aging assets, and therefore it requires a special attention. It's a challenge to the hydrocarbon sector as to how to maintain the integrity of these assets. How do you ensure the reliability of these assets? That's a major challenge, because if you are not able to maintain the reliability and integrity of the assets, asset integrity as we call, there will chances of catastrophic incidents which will lead to disaster. So that's a great challenge before the oil industry. The risk reduction approach, industry approach, I will talk, is shown in a triangle. The least preferred option is PPE. I'm not saying PPE is not to be used. PPE is required. So personal protective equipment is important. Administrative controls, they are also important. But the preferred options are engineering controls. What sort of engineering controls do I bring in to reduce the risk? How do you isolate the risk? How do we substitute the risk? And finally, what we can do to eliminate the risk. And therefore, it comes of inherent safe design. We'll talk about it as I go along through the process of inherent safe design, incorporating inherent safe design, how we can reduce the risk. We'll talk about it. So the most preferred option in risk reduction in our industry, every industry, not only in oil and gas industry, in every industry, the most preferred option is to have an engineering control. Through the engineering controls, how can we reduce the risk, or we can isolate the risk, substitute the risk, and finally, how can we eliminate the risk through some inherent safe designs. We'll talk about it as we go in detail. Risks in the hydrocarbon industry. There could be many risks in the oil and gas industry, and the risk could be from the economic risks, the environmental risks, the operational risk. There could be political risk, and there could be resource risks also. So there could be in broadly risk in the hydrocarbon sector, hydrocarbon industry, be it in the upstream industry or the downstream industry, can be categorized into 5 areas, 5 specific areas. We can have an economic risks, where because of the high oil price, etc., economic reasons, there is a very high risk in the oil and gas industry. Environmental risk, I will talk about in detail. Operational risk, political instability. As you all know, what happened in the Middle East way back due to Iran-Kuwait conflict and subsequent Iraq war, so where oil was not available. Resource risks. So there are certain 5 types of risks which are associated with hydrocarbon industry. I will focus, because this session is on disaster risk, and I will focus mainly on environmental risks and operational risks. Environmental risks are those risks which happen due to natural catastrophe, leading to interrupted or reduced production or industrial accidents. So basically, we talk about the environmental risk, which is due to natural catastrophic incidents, and operational risk. This is our focus of attention. This is our focus of area of discussion, which is major industrial accidents. Major accidents or oil spill. Now, oil spill have resulted in catastrophic incidents, as you all know. Deepwater Horizon, Mexican Gulf. As you know, oil spill has resulted in huge loss of life, loss to the environment, loss of lot of aquatic marine life, regulatory fines, civil liability, loss of license to operate, and reputational damage. When Bhopal incident took place, the Union Carbide Bhopal has got extinct today. So because it has loss of license to operate and reputation. Union Carbide was such a reputed company, but after the Bhopal incident, which resulted in tens of thousands of people, innocent people, losing their life, the company does not exist today. So therefore, any sort of operational risks is very important when you talk about disaster reduction. Risk mitigation options. We will examine what are the risk mitigation options in detail. And there are a number of options to minimize the risks of industrial accidents. And these are some of the areas where we must focus to mitigate the risk associated with oil and gas industry. So following options help in both avoiding the risk and mitigating the consequences of an industrial accident. The consequences of an industrial accident, as I have mentioned, is loss of life, loss of property, loss of reputation, low morale of the employee. That's very important. A major accident, if it takes place, it results in a low morale of the employee. So therefore, how do we mitigate the risk? Is increase focus on health and safety. That's very important. Inspection and process assessment. That's important. We'll talk about in detail. Communication assessment. That's important. Emergency response preparation. And insurance covering the cost of property and business interruption that most of the companies do. There's an insurance, and through the insurance covering the cost of property and business interruption. Every company has an insurance, and through which we also minimize the risk, where there is a step towards mitigating the risks. We'll talk about in detail. So the model which I thought I will share with you, it's very important. It has at the center stage is design integrity. Until and unless the design of the installation, be it a refinery, be it an upstream installation, be it a pipeline, be it a petrochemical plant, be it a fertilizer plant, design of the installation is very important. So therefore, design must be robust. That's very important. If the design is not robust, If the design is not proper, there will be chances of unsafe situation which may result in accidents. So therefore, look at the design at the inception stage itself. Look at the general arrangement drawing. Look at the P&I diagram. Look at the process flow diagram. Have you incorporated layers of protection, as we call LOPA? Have you incorporated layers of protection into our design? If you have incorporated the layers of protection in our design, then there will be less chances of any major accident, major catastrophic incidents, and as a result, there will be less disaster in our operation. We will be able to have safe, reliable, 24/7, smooth and safe operations. Therefore, design is very, very important. The equipment which you are procuring, the BOP which you procure, equipment which you are procuring, do they meet the necessary ASME or API standards? The maintenance of BOP has been elaborated in the API standards. Even the procurement of the BOP, which is used in our upstream oil or upstream business, in oil exploration business, in the wells, or the various equipment, the reactors, which are there in the refinery, the various static equipment, the LPG, hot and sphere, etc. Do they meet the ASME or API standards? So design is very, very important. Not only we must have a strong and robust design, we must also have operational integrity. By this we mean that we must know the nitty-gritties of operation. If we do not know the nitty-gritties of operation, if we do not know how to tackle an emergency, if you do not know how to troubleshoot, there could be a problem. So therefore, understanding, knowing the nitty-gritties of operation, the standard operating procedure is very, very important. How do we start up a plant? How do you shut down a plant? What happens if there is an emergency? How do you handle those emergencies? How do you troubleshoot them? We had a huge incident in Bhagavad in northeast of India, the oil India. What went wrong? Where did you make mistake in our operational steps? That's very, very important. If you do not do that, if you do not understand it, if you do not understand the nitty-gritties of operation, there will be catastrophic incidents and there will be disaster. Exactly what had happened in Bhagavad in oil India, in northeast of India. The entire area was shut down for more than 2 months. You are all ever. I'm not carrying coal to the Newcastles. You are all from upstream sector. You know about the incident which happened in oil India, in northeast of India. Third, so design must be robust. We must know how to operate. Other important thing is maintenance integrity. Your design could be the best of the design. You may have the best of the Mercedes car. You may know how to operate a Mercedes car, but if you don't maintain the equipment, if you don't maintain the various equipment, if you do not go for a preventive and predictive maintenance. And today we are going for risk-based inspection, particularly in the offshore regions. It's very, very important to have risk-based inspections. So if the company or if an organization depends upon breakdown maintenance, I'm afraid there will be unsafe situation, there will be catastrophic incidents, and as a result, there will be disasters. So how do we stop this? This model says that our design must be robust. We must know how to operate. We must also maintain our assets properly, and maintaining assets properly means regularly doing its maintenance through predictive maintenance, through preventive maintenance, through risk-based inspections, and through reliability-centric maintenance. These are very, very important things through which we can ensure 24/7 smooth and safe operation without facing any sort of disaster and reducing the chances of disaster. And finally, the most important thing is human durability. It is the people who moves the process and technology. If the human being in the organization, they are not properly trained, if they are not properly educated, if they are not properly motivated, your design be the best. But you will not be able to achieve highest level of reliable operation, and therefore there will be many unsafe situations. So this is important, to motivate the people, to educate the people, and exactly what is ONGC today has done, to train and educate the people. By training and educating the people, we are motivating the people. That's very, very important. So these are the four cornerstones of disaster risk reduction. My design must be robust. we must know how to operate, we must maintain our assets, and the important thing is the people. The people in the industry, they must be properly trained, they must be properly educated, they must be properly motivated. So that's very, very important. So therefore, operation, maintenance, design, and human reliability, these four together helps in disaster reduction. So stick to the fundamentals, friends. How do you reduce the risk? I always say stick to the fundamentals. Design, fabricate, and install all facilities and equipment in accordance with the applicable industrial codes. That's what I said. Follow the API standards, follow the ASME standards. So these standards should be followed, and some of the fabrication, some of the design, some of the, when you are installing the equipment, they must follow the best practices. The best practices. Operate facilities and equipment within design tolerances and safe envelopes. Do not operate any equipment or any facility, any refinery or any of your oil exploration systems beyond the design tolerances. If you go beyond the design tolerances, every equipment has a design tolerance. So if you go beyond the design tolerances, as we call safe envelope, then you're inviting problem. Discontinue operation when the safeguards are known to be impaired or rectify immediately. What happened to the mud tank? Have you ever thought in the Bhagavad case what happened to the mud tank? Was there any indication in the mud tank? Never keep critical safety systems bypassed or not functioning properly or not tested. Analyze if there are frequent process upsets. That's what I was referring. Do you get indications while operating the plant or while operating the upstream oil and exploration areas? No incident takes place, no disaster takes place, no accident takes place without giving a signal. We don't pick up those signals, we do not pick up those warning signals, we do not process those warning signals. So therefore it is important to analyze the frequent process upsets. Analyze equipment failure to determine their cause. So this, if we stick to the fundamentals, there will be safe operation, there will be reliable operation. We will be able to reduce the risks, mitigate the risks. If you have a proper design, fabricate properly, if you discontinue operation when the safeguards are impaired, or if you analyze the frequent process upsets, go to the root cause as to why there are frequent process upsets, and what actions we must take to correct and rectify the system. That's very, very important. Go into the root. Find out the root cause of the incident as to why did it happen, and the learnings of that incident should be shared with the people. Do not commit the same mistake twice. We learn from the mistake, but we should not make the same mistake twice. That's important. Now, if you look at the major disasters which has happened, major catastrophic incidents which has happened in the oil and gas industry and other industries, you will find that many times the same mistakes have been repeated. Therefore, it is important to stick to the fundamentals. That's very, very important. Okay. So let's move on to a catastrophic failure in a high pressure. I thought I will share this case study with you. A failure in a natural gas pipeline. An incident of fire followed by explosion took place in an 18-inch dia pipeline carrying natural gas. It resulted in multiple fatalities and substantial loss of property. Huge loss of property. More than 22 people lost their lives. Huge loss of property, and more than 22 people lost their life in that incident. Okay, the fire took place in the early morning, and the source of ignition was from a nearby shop. The shop owner lighted the stove for making tea at early morning. I will come to the detail. It took more than 3 hours for firefighters to extinguish the fire. The pipeline carrying the natural gas, which was carrying natural gas from the oil head of your own ONGC's oil head at Tatipaka. I should not name it. So it was passing below a canal, and that natural gas at a pressure of 45 kg used to supply the natural gas to far-flung areas, to fertilizer plants, to power plants. It was observed that there was water and condensate along with the natural gas, which is quite natural. The test report of the gas also indicated presence of carbon dioxide. You all know from a well, when you get gas, along with the gas, there will always be there some amount of water and some amount of condensate along with CO2. The pipeline was operating at lower capacity. What does it mean? Lower capacity means lower velocity. Lower capacity means lower velocity, and whenever there is a lower velocity, there are always chances of internal corrosion. Exactly, internal corrosion happened in the pipeline, and there was also some external corrosion, because when we investigated, I investigated the incident. When we investigated the incident, we found that there was external coating of the pipe was damaged. There were past incidents of leak at 6 o'clock position. At 6 o'clock position of the pipe, which was carrying natural gas and passing below a canal, at 6 o'clock position, there were leaks. The mine that the pipeline was transporting natural gas at a pressure of 45 kg per centimeter square at 45 bar. So every time there was a leak, the leak was repaired by a clamp. If you are repairing a leak by a clamp, that's not a proper method of repairing it. So that's what I said. One early morning, profuse natural gas leak took place from the clamp 6 o'clock position of the pipeline, because number of times, 7 or 8 times from the same 6 o'clock position, there used to be leak. And then every time the company, the operator, resorted to clamping. Clamping is not a solution to a 45 kg pipeline. You have to go into the deep root as to why there is so much of leak and what action should be taken to prevent the leak from the same position a number of times. But it happened so. At the 6 o'clock position, there was leak. It was a profuse leak of natural gas. I will come to it. It was an overcast morning, and therefore natural gas could not escape. And as I have mentioned, early in the morning, some tea shop owner lighted a stove, which provided the source of ignition. There was a huge fire. An explosion. As a result, multiple fatalities, and I have seen the entire area. And you may all be knowing. Many people are from. May have come across this incident. Many palm trees over a large areas were totally burned. It resulted in loss of multiple fatalities and huge loss of property and damage to the environment. What went wrong? What went wrong? Let's look at what went wrong. As I have mentioned, if you want to reduce the risk of the disaster, our maintenance has to be strong. There were a number of times there was a leak in the high pressure pipeline, 45 kg pipeline, feeding natural gas to far-flung areas, to power plant, to Lanco power plant, to fertilizer plants in Vizag, etc. And every time we resorted to clamp the high pressure pipe. So improper maintenance adopted by the operator, clamps in the high pressure pipeline, is a poor maintenance practice, is a poor maintenance philosophy, and that has resulted in this catastrophic incident, a huge disaster. Now, whenever there is a cross-country pipeline or pipeline, there are sectionizing valves. That's even if some portion of the valve there is a leak, you can isolate that portion of the pipeline so as to minimize the damage. And therefore, remote operated sectionizing valves were provided in the design. As I've mentioned, the designer in the design has provided remote operated sectionizing valve. He visualized that there are chances, there could be some leaks, and if you want to isolate that portion of the pipeline, which should be done, because you want to reduce the risk, you want to minimize the damage. So therefore, remote operated sectionizing valves were provided to isolate the section of the pipeline, but they did not function and operate because we did not maintain it properly. It had to be manually closed. And when somebody in a pipeline, cross-country pipeline, if you go to the spot and close the pipeline manually, a lot of time is lost. And during that period, huge amount of natural gas leaked from the 6 o'clock position of the pipeline. So this was one maintenance fault. Operational philosophy. Proper pigs were not used for cleaning the pipeline. Instead of scrapper pigs, foam pigs were used, which is not which should not be done. And pigging was not also carried out at regular intervals. So we must know how to operate. Pig residue should have been analyzed, because if you analyze the pig residue, it should have said that there is a lot of iron content in the pig residue, which should have given you an indication that a lot of internal corrosion is going on in the pipeline. Improper method of operations. Instead of using scrapper pig, we used foam pigs. That's wrong. Design. Now this is very, very important. Please understand this. This is very, very important. The gas from the wellhead contains some amount of water, some amount of condensate, and CO2. The pipeline was designed to handle dry natural gas, but it handled wet natural gas. Why? Because in the design, the designer had envisaged a dryer. The wet gas will pass through a dryer, and then the dry gas will be put into the pipeline. But the dryer envisaged in the design was not installed. And as a result of that, there was corrosion, accumulation of water, CO2 mix in the line, and you are not doing pigging properly. You have not installed the dryer, so therefore there is water. And as a result, when water, CO2, etc., are there, bicarbonic acid, internal corrosion took place in the pipeline. And even that internal corrosion took place in the pipeline, there were leaks some 8-10 times in the pipeline, and every time the leak was ignored, and it was a poor maintenance philosophy. Clamping a 45 kg pipeline was resorted to. As a result, there was huge explosion. More than 2 dozen people lost their life, and huge area where huge damage to the huge area. Finally, you also see this. We do the IPS. The IPS was conducted 4 years prior to the failure, indicated metal loss at the vicinity of the canal. But the operator ignored the findings of the report, and the report suggested, even the IPS report suggested, that so much of money we spent for doing all these things. IPS report is done by an expert outside the agency, German party. Experts from Germany did the IPS. And they suggested that internal to overcome, to mitigate the internal corrosion, to reduce the risk, to mitigate the risk, corrosion inhibitor has to be added. But the corrosion inhibitor was not added in the person. So this IPS report, the German company did the IPS. The IPS report suggested that to mitigate the risk, to mitigate the risk, corrosion inhibitor has to be added. But the corrosion inhibitor was not added into the pipeline carrying natural gas. And as a result, there was leak and huge incidents. So what did we learn from the incidents? Scrapper pigging should be done, as I have talked. Foam pigs are not to be used. Instrumented pig survey must be carried out once in 10 years. Corrosion coupons must be installed. Now, these are some of the fundamentals. In case the internal corrosion is more than 1 mils per year, corrosion inhibitor must be injected in the pipeline. So these are some of the fundamentals. We must stick to the fundamental, as every time I mention. Stick to the fundamental to reduce the chances of risk, to mitigate the risk. A pipeline integrity management system should be prepared, institutionalized, and followed for assuring the health of the pipeline. Important. Leak detection system should be provided in the line. Everybody does it. We must also do it. Over dependence on third-party agencies should be avoided. Company's own supervision is needed to strengthen. In our country, we rely heavily on contractors, and we don't supervise. Poor supervision has led to many catastrophic incidents and disasters. Okay, and for the pipeline, other important thing is encroachment in the pipelines in the right of way. Any change with respect to design parameter must be incorporated after carrying out a detailed technical analysis or management of change. That's very, very important. Dehydration facility must be provided. And today, every place, the dehydration facility has been added. Pipeline which are more than 25 years old, residual life assessment must be done. So these are some of the recommendations, and many of the things have been done by the company to overcome the problem. Now let's talk about the performance improvement cycle. Effective crisis management starts with risk identification and prioritization, as I have talked about it. Identify the risk and prioritize the risk. Number two is the step is planning and control. Emergency, if in case your design is strong, you know how to operate, your maintenance is good, there will be less chances of any sort of accident or disaster. But then if disaster happens due to reasons, force majeure, or due to reasons beyond your control, we must have emergency response disaster management plan. Every organization, every institute must prepare a year DMP, as must conduct mock drills. Why do you conduct the mock drills? The mock drills are conducted to ensure we are prepared to handle the emergencies, and therefore we suggested to do both on-site and off-site mock drills. Once in a quarter, at least once in a quarter, on-site mock drills must be conducted on various scenarios. Do the on-site mock drills. These are part of planning and control. And once in a year, do off-site mock drill. Implementation and operation, that's very, very important. Assess the situation, protect life and assets, and implement the plan. So first step for performance improvement cycle to effectively manage the crisis is identify the risks, prioritize the risk. Number two is planning and control, where you talk about the control mechanism measures as mock drills, year DMP, emergency response and development management plan. Then implementation action is assess the situation, implement the plan. Finally, we come to management evaluation, restore and repair, debrief, evaluate the plan. After every mock drill, we must have a debriefing session. Evaluate the plan. If there are certain aspects which are required to strengthen the plan, do it. And that's the job of the management. Evaluate the plan. That's how we can improve upon the performance improvement cycle. And finally, we must have, after any sort of crisis, we must have a post-crisis review. A post-crisis review should be done at the top management level so as to bring about improvement. It's a situation of continuous improvement. We learn and do the improvement. And that's how only we can improve the performance improvement cycle. So the step starts with the risk identification, planning and control, implementation, management, and management review. These are some of the steps to go for performance improvement cycle. Now there are some barriers to effective crisis management. I will share one by one. Denial and fail to prioritize. Most of the time we are in a mode of denial mode. We ignore the warning signals. Now, if you ignore the warning signals, because as I mentioned, no plant and machinery breaks down without giving a warning signal. Now, if you are ignoring the warning signals, you are in a mode of denial. And failure to, and therefore, the risk or a hazard associated are not being identified. And if you fail to prioritize. Number two could be that you lack experience. The persons who are doing the hazard study or hazard study or risk reduction study, they lack experience. And therefore, it's a potential risk. Inadequate systems, process, and discipline. These are some of the barriers to effective crisis management. Insufficient size and resources. And finally, unwilling to share experience. That's very, very important. We learn from the disasters. From Bhopal disaster, we learned. From Jaipur incident, we learned. From Piper Alpha incident, we learned. Now, if you're not learning, if you're not institutionalizing the learning process, mistake, human beings make mistake. But we should not do the same mistake twice. That's not acceptable. That's a sin. Ordinary people like us commit mistake and learn from the mistake. The wise learn from the mistake of others. So therefore, if you are not willing to share experiences, how can we reduce the risks? How can we reduce the disasters? And finally, failure of leadership and communication. We need to communicate. We need to communicate. Talk to the people. We are very comfortable in giving instructions. My dear friends, giving instruction is not enough. You must engage your people with the discussion process. Engage them in a discussion process. Learn from each other. Motivate the team. In the process, you will be able to identify the hazards in your operation. In the process, you will be able to reduce the risk in your operation. And that if that happens, there will be no sort of disasters in our operation. Finally, the emergency plan and preparedness. Being ready for a crisis depends upon three important things, three critical dimensions for building a well-managed crisis response plan. Number one is the people. Is a human resource. That is the number one focus. Develop formal and informal arrangements. Not only formal, informal arrangements, friends, are very, very important. Ahead of time, and specify how to respond in case there is an emergency. Be proactive. Preparedness. Preparedness means analyzing ability to respond quickly, and therefore we conduct mock drills. Preparedness. There are various scenarios, and on those scenarios, conduct the mock drill to respond quickly and effectively for the possible crisis most relevant to your areas of operation. For upstream sector, there could be various scenarios. And finally, third is the testing. People, preparedness and testing. Rehearse a simulated crisis. Create a simulation, create a crisis, mock crisis, and see whether people are properly trained and educated to handle that crisis situation. Rehearse a simulated crisis that requires you to show that you have got contingencies covered. There could be various sort of contingencies, and that can only be covered when you're doing off-site mock drill once in a year. So these are the three critical elements, three critical dimensions for building a well-managed crisis response plan. The challenges, my friends, is time is the key. If you lose time, for example, in the pipeline, the catastrophic example of natural gas pipeline, which I have cited, the important thing was to have a remote operated sectionalizing valve. Remote operated sectionalizing valve should be operational. But the remote operated sectionalizing valve did not operate, and therefore the valve was to be closed manually, and the precious time was lost. And during that time, a lot of natural gas leak took place. People are the top priority. Key information in decision making, task performance, monitor things which get monitored, gets done. If you're not monitoring, if you're not measuring the KPIs, things will not happen. Provide resources. Once we have done the planning, and if there is any shortfall in the planning, through the control mechanism, provide resources. The crucial importance is objectivity. Bring in objectivity. And if you bring in objectivity, most of the time organizations fail because they cannot bring in objectivity. And that's a great challenge to the organizations. Okay. Finally, what is the role of emergency response team leader? As I mentioned, assess the situation, secure the area, activate incident command system in case, God forbid, this does not happen. In case there is a disaster type of situation, activate incident command system. And what does activate do? Single incident command, evaluate the situation, ground communication must be strong until and unless people are communicated, until and unless people are told what to be done. Their role and responsibility must be clear. Identify the strategy, roll out the action plan. If you have made an action plan, roll out the action plan. Review, evaluate, and revise the plan if call are required. No organization can handle such type of mega catastrophic incident on their own. So therefore, you must have a mutual aid partner. Call for external assistance. IOC, BPC, HPC, ONGC, everybody has a mutual aid partner. And the thing is, work together, work shoulder to shoulder, work in a team. God forbid, there must not be any disaster. But in case that happens, you must have an emergency response disaster management plan, and then work together to mitigate that plan. Finally, as I've mentioned, I will talk about a little bit of concept about attributes of a high reliable organization. High reliable organization accepts a much higher level of false alarms. And since we accept a much higher level of false alarms, our operations, we ensure smooth and reliable operation. HRO gives strong response to weak signals. They set threshold limit for intervening very low. Something does not seem right, they stop operation and go deep root cause to find the root cause as to what happened. Investigate. High reliable organization accept a much higher level of false alarm, and their preoccupation with failure. HROs do not ignore any failure. It is necessary to address any level of technical, human, or process failure immediately and completely. They don't simplify. HROs don't simplify. Do not explain away problems. Instead, they conduct root cause analysis and reject a simplistic diagnosis must be rejected. Their sensitivity to operation. HROs understand that the best picture of the current situation, especially an unexpected one, comes from the front line. Be sensitive. Be sensible. That's very, very important. Commitment to resilience, flexibility. Flexibility in HRO means the ability to anticipate trouble spots, and that comes from your experience, that comes from your expertise. Anticipate trouble spot, and improvise when the unexpected occurs. Name of the game is improvising when you are handling the many sorts of catastrophic incidents or disaster. You must be able to anticipate trouble spot and improvise when unexpected occurs. And finally, that's very, very important, difference to expertise. Expertise rather than authority takes precedence in HRO. Domain knowledge is very, very important. Authority is not important, friends. I am general manager. I am executive director. No, expertise is important. When conditions are high risk and circumstances change rapidly, HROs understand that on the ground subject matter experts are essential because they know what to do. And so therefore, developing expertise is very, very important. And you can only develop expertise provided you have experience, provided you have knowledge, provided you have skill. Knowledge is what we acquire in our academic institution. Skill is the practice of the knowledge. That's very, very important. And when you have experience, 10 years, 15 years of experience, then you develop expertise. And HROs, high reliability organization, focus on expertise rather than on authority. So therefore, HROs are successful in preventing undue risks and disasters thereof. So through this model, we will be able to reduce the risk. We will be able to eliminate the risk, bring down the risk to as low as practicable, and in the process, we will be able to reduce the disaster in our operation. I thought for class for 50 minutes, I have spoken about it. If you have any questions, I have my Gmail here, iraq1955@gmail.com. You can also raise your questions in the chat box. I will answer to the chat box. Thank you, friends. Thank you, Anilji. Thank you.
Thank you very much, sir, for your informative presentation, highlighting the risk in hydrocarbon industry and some major catastrophic incidents that jolted the hydrocarbon sector, as well as model for risk and accident reducing approach for the sector. Our participant from hydrocarbon sector will be definitely profited from your talk. Sir, there is one question for you.
Yeah.
There are many risks.
It is in the chat box, yeah.
No, sir, it was sent to host privately.
Yeah.
Question is, there are many risks in the hydrocarbon industry, such as economic, environmental, and operational, and so on. What are the criteria to prioritize this risk?
Yeah, as I've discussed that The risks could be many. Risk could be because of economic, risk could be because of political, risk could be because of the environmental, and risk could be because of the operational risk. So we focus mainly on the in industry, right? In our oil and gas industry, the political risks we are not talking about. The economic risk we are not talking about, because they are given. So political unrest, I and you cannot control. It's beyond our the economic situation is beyond our preview in the industry. The operational risks, that's what we are talking about. The operational risk assessment is very, very important. Now, look into the design. As I've mentioned, look into the design. Every risk, the model is look into the design, look into the operation, look into the maintenance. Are we doing a proper maintenance? To have a preventive and predictive maintenance schedule, not handing over tanks for your maintenance, then we are losing an opportunity to check the health of these tanks. For example, every tank has a maintenance schedule, rollout plan. So if we want to improve the asset integrity of any of the organization, the tanks have a 5-year. After every 5 years, tanks must undergo major maintenance and inspection, or a unit must undergo a shutdown after 3 years. Now, if you are deferring handing over of equipment, then you are causing, then there are chances of a risk that tank may leak, or there could be some sort of catastrophic incident. So therefore, you must have a preventive and predictive maintenance, and stick to those preventive and predictive maintenance. These are maintenance aspects. Operational priority is if there are some upsets in the plant. Are we identifying those upsets as to why those upsets are taking place, and analyze those upsets as to why those upsets are taking place? That will give you 1, 2, 3, 4, 5, 6 long lists as to why these upsets are taking place. Is it because of lack of knowledge? Is it because of lack of some process modification has to be undertaken in the corporation, in the plant? Is it because of the metallurgical failure? Is it because of the corrosion failure? So depending upon the situation, for example, the natural gas pipeline failure example which you had given, the number one risk was the design failure, not the designer failure. The design failure, not incorporating the dryer which has been given by the designer in the plant, was a major failure. That's a major risk. Designer has said that the wet gas cannot be fed into the pipeline, so therefore dryer has to be incorporated. Now, if you have not installed a dryer, it's a huge risk which you have taken. So number one risk is that. Number two, operational risk is any pipeline, we must do the scrapper, we must do the pigging in periodically. Now, if you are not doing the pigging periodically in the time scale, that's an operational risk. And number two, you have to do the pigging through scrapper pigs, and you have used the wrong pig, foam pig. So if you're not using the proper pigs, so these are some of the operational risks which are there. So we have to identify each of the operational risks. So the best step is look at the P&I diagram. Look at the piping and instrumentation diagram. Piping and instrumentation diagram, analyzing the pipe, looking into the piping and instrumentation diagram, we will try to identify hazards in every operation, identify the hazards, and once you identify the hazards, we come to this next step of risk mitigation measures. Kya Mahavar ji? Vitragash ji, Mahavar ji? So step is look at the P&I diagram, look at the P&I diagram of all the installations, identify the hazards, and then once you identify the hazard, that is called hazard identification, and then for each of the hazards have the risk mitigation measures. It could be due to design, it could be due to operation, it could be due to maintenance, it could be wrong placement of a valve. If the valve is placed wrongly, that it could also lead to some sort of incident or unsafe situation. So at every step, thoroughly look into the P&I diagram. P&I is the, and today the P&I we have 3D P&I diagram. Sitting in a conference room, we can run through the entire plant. You can run through the entire plant in a 3D plot and look at the plant sitting in the, and then tell the designer by a multidisciplinary group of chemical, mechanical, geologists, or whosoever is there, tell them these are some sort of modifications which are required in the plant, so that we can overcome or mitigate the risks we can identify the hazards and give solutions to mitigate those risks.
Thank you very much, sir. Thank you very much for joining with us.
Yeah. So those written, there are some. Are there some anything more in the chat box?
No, sir. There was only one question.
Okay, then. So thank you. So you can send me the question directly to my Gmail. All the participants
Sure,
can send me the
sir.
question to my Gmail. I have overstepped the time, so it's now time for Mahavarji to speak. Thank you.
Thank you, sir.
Thank you, Hirakji. Thank you very much.
To discuss how to enhance the capabilities of the stakeholders in hydrocarbon sector for better preparedness and response. So I hand over the mic to Shri Ved Prakash Mahawar. He is presently Board of Governor, acting chairman of IIM Rohtak. He retired in 2018 as director of India's biggest oil and gas Maharatna upstream company, ONGC, New Delhi. He is also advisor to Green Tech Foundation, New Delhi, and is an ex-chairman of SPE Delhi chapter. He is also serving as president of Society of Health, Environment, Safety, and Sustainability Professionals, New Delhi. Over to you, sir.
Okay, Anil, thank you very much. I welcome all the participants, and Mr. Hirak Datta has spoken many things, many things about the DRR. But I will be touching many, what are the things which I'm going to touch is the practical aspects. What are the things, what are the preparedness required, and how we have to take action if the disaster has taken place, and the learnings from those disasters, how it can help us to improve the system in place. So,
Excuse me, sir.
sir?
Sir, you are audible, but your presentation is not visible. I think you haven't
No,
shared it.
I have not shared the presentation. I'll just share the presentation.
Okay, sir. You are audible.
Yeah, now I have started sharing my presentation. I shared my presentation now. So, friends, I'm going to talk about enhancing the disaster capability response and preparedness. As you have seen that Mr. Hirak Datta was speaking about DRR, and he has covered many things very nicely. But my presentation will be based mostly on the practical aspects, what I have faced or what my team has faced in the field, and what kind of learnings we have imbibed from that, and how those learnings have improved the systems in ONGC as well as the other oil industries. So I'll be talking about those. So if you see, just move this. Okay. So what is a disaster response basically? If you talk in words, it is managing the consequences of the disaster and providing immediate relief. I'll be discussing this, what is this immediate relief, as well as taking steps towards restoring normalcy. So how these things can be achieved, I'll be going step by step, and we'll be discussing in my presentation. So effective response in disaster. Disaster response is effective, as Hirak was telling that we should go for a drill and all. So this, we conduct those things. These are the things which we have to focus on. Number one is the action taken in the initial minutes of the emergency circuit. This is, I think everybody will agree with this. Yes, if you take early actions, like Hirak was telling, that we can early warnings if we pick up and we can warn the people, that will definitely help to save a lot of people as well, equipment as well as environment. So the action taken in the beginning is very, very critical. How fast to take action. So here the response time takes a very, very important place here. This response time we can reduce by drills, as we'll be discussing in my subsequent slides also. Another is the prompt warning to employees to evacuate and shelter and save life. how fast we can evacuate the people from the disaster place, and how this can be achieved. I'll be discussing those points also, because we have faced a lot of problems in India as well as abroad, and how the things were done by us and by our team of ONGC, that I'll be discussing here. Providing full and accurate information to emergency service needed during disaster. See, this can only happen, what are the things needed, when you know about something about that disaster, or when you are keeping yourself involved with the disaster, and the right information if you are giving, then the right kind of equipments can be mobilized, so you can mitigate any of the disaster in a fast way. So this is another important thing, so how you are informing about the disaster. The information from the disaster side is an important factor to bring the right equipment and right people at site to fight that disaster. Number 4 is knowledge of area and process system of the process system employee can help. See, the person who was working there or who was involved in that operation should be associated with the disaster team. The reason is, if a person is knowing about where to go, what are the equipments, what are the safe passages from where the person can go, so he or she can provide the right information to the team who is going there to control the disaster. So that is a very important thing, because sometimes we find that the person who has not even visited the site has been assigned and told that, okay, you go and work with this team and this guide them, and he is not aware of anything. So that should not happen. I think that is not the correct strategy. So I'm just putting a small video here. If a disaster takes place, how much time it gives. See, if this has happened in one of the rig, which I was also present and witnessing. If you see a person standing here is one of my colleagues and who was supervising, and how much time it has given. He was going to just to see if there is a flow. And this is the fate of the oil and gas industry. So it is very, very important in oil and gas industry that you should be very vigilant, act fast. If you are not doing that, this kind of thing can happen which is in front of you. So friends, this is one of the disasters which was captured by our team and witnessed by our team and was controlled by our team. So this is how things can go wrong, and if you're not taking right action, what can happen. So this is one small clip which I have shown it to you, and it has happened. So now this rig completely melted and it was difficult to control. So now you have seen the disaster, how much time it gives. So if you are not prepared, if you are not acting in time, what can go wrong and what can happen. So if we have to reduce these kind of incidences, what is needed, I am going to discuss those points. Number one, if you see the response plan, when you are making an emergency response plans, we talk about emergency response plan, this should be there, that should be there. And any emergency plan which you are making should be crisp and with no elaboration in that. If you are taking that, do this, that's all. You don't explain why to do this, because I have seen in many of the response plan, they said you call fire tender, but why to call fire tender, there is also not mentioned. Use fire extinguisher, and there they will explain which kind of fire extinguishers to use, this and ये इसमें DC इसमें ये होता है, इसमें ये होता है, ये सब चीजें की जरूरत नहीं, because you should be giving instruction only in the response plan. Do this, do this, do this, and do this. The person who is reading will be able to read it. He need not to see that why I'm doing it, that he or she has to think on that. So any disaster response plan should be like that only. And the topmost priority should be given to the protection of the people, because we have experienced people working in the field. So we have to see that how we can protect those people. So whatever you are plans you are making, things you should see, keep in your mind that yes, the person working in the field is important for us, and his life or her life is very important for us. So let us work in such a way that the person working there is safe. Another thing, very important thing, is protection of environment. That is very, very important, as Hirak has also explained about that. Nowadays, because we are dealing with the inflammable material, so if it spills, it creates a lot of havoc, and definitely the environment is polluted. So we have to think that how we can restrict the flow of the hazardous fluid which is coming out, or inflammable fluid coming out of the wells, so it will not pollute the environment. So what kind of preparedness we should have, I will talk in some subsequent slides what are the actions you have to take, and if you are prepared, then how you can save this environment also. Protection of the company property, because the equipments which we are using in oil industries are very costly. Most of the equipments are imported. Few things are being manufactured in India, but definitely if you have to again restart, bring things to normal and operate, if you are losing these equipments, bringing those equipments, the lead times are very high. So one should keep in mind that how we can save, how we can protect our properties. So this also I'll discuss in subsequent slide. And protection of the resources. Now, as you all know that oil and gas is a very precious resource for us. If you talk about our consumption and the production, we are producing only 14% of oil of our requirement and about 50% of the gas of our requirement. And now government has also said that we want to increase the gas percent in our energy sector, or in a basket, the 6% contribution to the gas, and the plan is by 2030 we will be increasing it to 15%, 1-5. So this is really a great challenge for all of us, and definitely it will pose a challenge to oil and gas industry. Now, response competency disaster required in disasters. So I have categorized in three steps this one. First one is the primary response, and second is incident reporting, and third is a secondary response. So these are what is primary response, what is incident reporting, and what is secondary response. This I have elaborated a bit, so I'll just come to that. Primary response is number one, location abandonment if needed, because these disasters are not small. Sometimes big disaster comes, like Hirak was talking about Bhagavad. Initially there was no fire, and after that there was a fire, and when the fire was there, things were different. When there was no fire, in about 1.5 to 2 kilometer area, the lot of sound was there, but the pressure was 3,500 psi. So people were evacuated and sent to the shelter homes. And when there was fire, things were different, because there's a lot of heat generated, a lot of houses got damaged. And so that area to be abandoned, and how this abandonment can be done, that also should be kept in mind when you are making a response plan. Another thing, search, rescue and recovery. Because if you see there, again I am talking about Bhagavad because it's a very recent incident. The fire people were working there because there was no fire, and suddenly there was a fire. There was an escape route made that people should be passing through that route in case of fire. But unfortunately, two of our colleagues, two of our friends have jumped into the nearby water body, thought that there is only 4 feet of water we will be able to pass through, but there was a lot of mud, slushy area, they got stuck in it and they could not come out. So this also a very, very, I think, important point, that everybody who is working in a disaster situation should know that in case of any emergency, it happens, a already emergency, and there again, if something happens, where he or she has to run. So the escape routes are to be there, and if somebody is hurt, then we should be able to help them, and where the person is to be taken. These all things are to be there in the response plan, because if you see in Bhagavad, we used to keep one helicopter ready all the time when we are doing all the operations, and nearby school was made as a point where the helicopter can land and rescue the person from the disaster place or from that area. So that kind of preparedness should be there when we are. So this all comes under a primary response, because these are the things which will save a person. Protection of facilities, yes. Moving of equipments. If I talk about Bhagavad, my observations. There was no fire in the beginning. If you would have removed all the equipment, because this is the first thing which one should do. If there is no fire, try to pull out all the equipments which are there, because if any emergency is there and there's a high pressure there, so it is important that we should make a place to work freely there, and in that process, we should remove all the equipments which are not required. So, and that can be done by spraying water. But water spraying is also a big relief. If you put a water, it prevents fire, because whatever the fluid coming out from the well will not ignite. And second, it will help you to work in that environment very safely in case a fire happens, because you are already wet, so you will not get hurt to the extent. So this is another thing which is a part of the primary response. First aid and trauma center, these are the centers which are to be identified, kept ready to be mentioned. All the numbers and contact persons should be there when available in our response plan, that yes, in case an emergency, where the person will be taken. In case of Bhagavad, there were 2-3 places which were identified. If there is a burn injury, will be taken to that Dibrugarh, or if another injury nearby Tinsukia was there, the people were to be taken there. So this kind of plan should be there in place. Another thing is incident reporting. How to report the incident. So the reporting, one is reporting in the company, how we are going to report into the company. It doesn't mean that everybody start talking to your boss. No, it should not happen in case of disaster, because the person who is responsible or head of the institute or sitting at some place, if everybody start, nowadays mobile are there, everybody will start talking to them. No, only the authorized person should give the information to the concerned officer or executive. It should not be like that, everybody start, because I know boss, I'll inform. No, it should not happen like that. Friends, in emergency, it is very, very important. If you start talking to things, and in this situation, the actual information which should reach to the concerned authority, concerned person, will not reach. So if you are not authorized to report, you are not in the chain, don't talk to anybody, do your job. So that should be kept in the mind again. आप बोल रहे हो, मैं बार बार हाथ को लगा रहा हूँ कि ये माइंड बहुत इंपॉर्टेंट है, बिकॉज इसको कूल रखना बहुत इंपॉर्टेंट है. Reporting to external agencies, and again, to whom we have to inform, that should be there. Now we have to report to the government authorities. Definitely we are a government institution, definitely it is required. The regulatory, the authorities are there, like I was telling that OSD he was heading, so, and the media. The most critical thing is the media. Because nowadays people will take some photograph, some small picture hiding behind the tree and send it to the media and they'll make it a big hype. So please don't do that, because that will ruin the, you can say, reputation of your company. Anybody is working should not do that. And don't talk to the media if you are not aware of the situation or action plan, because everybody is not knowing what is going to do. Don't think your own plan and tell to somebody else and they make it a big no fuss out of it. So that should not happen. If anybody is not authorized, or if you are not authorized to talk to the media, don't talk to the media. Then only the authorized person should be talking to the media, giving briefing to the media, because we know what are the things to be informed, which are important for the company as well as for the people around that area. So this should be strictly followed. And the flow information, I have just given a chart that how the flow can be given. So this kind of flow information can be made, so the person knows that who is there, whom to be informed. So this is one example I have given. You can make as per your plant, as per your asset or basins, or as per your area of working. Now the secondary response. Secondary response means when the disaster has taken place and now we have to control the disaster. So when you are going to control the disaster, at that time, building action plan for a specific emergency. All the emergencies will be different. If you think that two emergencies will be similar, no, it does not happen, because I have controlled almost 36 blow in my entire life of 37 years of working in ONGC, and as well as now also after retirement about 3 years. I have seen there's no two incidents which are similar. All are having some difference. So the action plan should be made as per the situations there. And don't think that I have done this thing in the previous well, it was done like that, the same thing will work here. No, that does not work. I'll show you some of the example in my next slides, that how the information which has been given is sometimes misleads you, and the plans which you have prepared fails. So recent incident also I'll talk about. Now execution of the action plan. How we are going to execute, who will be involved, and how the plan will be executed. That is again an important thing, because once we are executing any plan, sometimes we make a team and say suppose 3 teams are going to work here, the plan has been made, you go there and work inside. But in any of the plan which you are executing, don't add anything instantly when you are working in the disaster place. This can create a very big further disaster in that area. So if you are working in the disaster area, whatever has been told to you, do as per that plan. If you find that what has been told to you, there is some difference, or we need to put something else there, or we have to apply some another technique there, please come out, discuss, and again go back. So don't do anything instantaneously which is coming to your mind when you are handling a disaster and when you are inside the disaster place. So this is one thing everyone has to keep in the mind, because we have a habit, ठीक है इसको मैं खोल देता हूँ, क्या फर्क पड़ेगा. But you don't understand the gravity of the situation, because the plan has been made by a team or a person who is responsible, because he has something in his mind that, her mind, that how this will be happening, or if this happens, you open a wall, but that can lead to some other problem to the other team who is working there. So don't do anything which is not told to you and not as per the plan. if something untoward has been seen, come out, discuss, and take the right action. Identification and mobilization of resources. So this again, what are the resources required and where these resources are available. It's not necessary that you will have all the resources required for handling the crisis. So in this, we can have some tie-up with the state government, with the other companies, so that in case of any emergencies, if any equipment is required, that equipment can be brought to the disaster place and the disaster can be handled with full precautions and safety. Monitoring of progress again. So whatever plan has been made, and then how we are monitoring that, because plan is made and if you're not monitoring, it's not like that whatever you have made, oh, let's do it, let's take days together. No, it's not like that. Plan has been made with the timeline. If you see that timelines are not met, why these timelines are not met, if some problem is there or some corrective actions are required, let us do those corrective actions. Because not like we were talking in the Bhagavad, we thought, yes, this problem will be done in 21 or 22, 4 days, but nobody was knowing that the fire will be there. When the fire was there, when we installed the capping stack, nobody was thinking that the side outlet wall will blew at 2500 psi, which is meant for 5000 psi. So these are the things which will happen at the site. Then you should be prepared to take the corrective action. So this is another thing. It should not happen like that. Now what I should do, what I have to do. So you have to be having the action plans ready in your mind. See the another incident plan, how the incident can be handled properly. If you have this plan in place, who will support whom and who will do what, and this kind of planning can be done. And in ONGC we have this kind of planning. The incident management plan is already there. Each assets, each installation, and they know that what is to be done. So people know in case of emergency what is how they are empowered. That is also given in the BDP. So this is another thing. So I'm just talking about one incident. I'm not telling where it was happened, but why the right information is required. So if you see this well, it is blowing. The gas is coming from the top, gas is coming from the side outlet, gas is coming from the wellhead. See, a lot of gas if you see there. So we thought the information was given that we have a, if you see here, this is a tubing hanger. They said we have a tubing hanger, a tubing inside. So we thought, oh, it's very simple. We'll be able to do it in a day or two. This is the incident which has happened. The line was connected, and we thought we'll be pumping here, and the well will be killed in a day or two. But when we started pumping, see, this was the plan. The plan was made, pump heavy fluid, it will go inside and will come through the tubing, and the well will be subdued. It's a 1 day or 2 days job. But actually what has happened, when we start, this is what has happened. Whatever we were pumping, it was coming out immediately to the surface. So this has given an idea that whatever the information which was given to us is not correct. And finally we found that the information given was the tubing hanger is there and tubing is hanging. Whereas there was no tubing hanger, the tubing flange was there where the tubing was tight. So why the correct informations are important. So in that case, what was done here? Now, if you see the action plan, now you can't kill this well like this. This complete thing was cut, removed, then all the equipments were removed, the rig was removed, and another capping stack was installed on top of that. So that took almost 7 to 8 days. Initially, the plan was we'll do it in 1 or 2 days, but actually it took almost 7 to 8 days. So this is how this correct information, if you are not giving, the things can go wrong. So please friends, if you are not aware of the place, and you are not knowing, don't give wrong information, lead to other problems. Now I'm talking about unique challenge during disaster. So these are the challenges which, one is environment protection. Yes, it is very, very important because we have to see. And the population nearby, I already talked that nearby population, basically, when the people are not aware, a lot of sound is coming and they can't sleep. They said we can't sleep in that area. So definitely they are to be evacuated. Shelters where they can be provided food and proper sanitations, everything. So that is a big challenge basically. If you see in case of Bhagavad, again I'm talking about Bhagavad because it is an incident and a lot of publicity was there for Bhagavad. So there were almost 3,000 people were evacuated from the nearby place, about within the 1.5 kilometer vicinity. They were placed in the nearby schools. Everything was provided to them. And you know, friends, there's a Corona time, so it was challenged that people should not have that Corona effect. So they were given proper mask and proper briefing were be given. And because of the safe distancing, number of persons in the room were also restricted. So this kind of thing was the challenge was there. But another challenge is that political challenge which Hirak Datta was talking about. Somebody say, no, I am 10 kilometers away, but wo mera ghar hilta hai wahan pe. I'm unable to sleep there. And when you go there, you take all the things, nothing is happening. But we got some compulsions that these people also should be kept in the camp. So in place of 3,000, the number increased. It went about to 6,000. People start exploiting those situations. So friends, this is a challenge during disaster, how to handle this. Like the political challenge is one of the very big challenge which we have to handle very carefully and amicably. And another thing is prevent fire. If you see here, initially we were able to prevent fire with the fire tender. And in case of Bhagavad, if you would have installed the high discharge pumps in time, we could have put the water on top here in this place because the fire tender has the limitations. The water was going up to only part of the derrick, but it was not going up, whereas the gas was flowing from the top. And there was a lot of pipes there installed, were there, and they were, because of the force of the fire fluid which was coming from the well, they were just rubbing each other, and the spark was there and there was a fire. If the high discharge pump could have been installed and put on the top, this fire could have been prevented. So this is another important thing, the control plan. Now I'm just going to talk about a very recent incident which has happened, and I have come back yesterday from that place. There was a well in Dandewala in Jaisalmer area started leaking because what has happened was this well was producing, it was drilled in 1990 and it was producing about 1.5 lakhs of gas, and over a period of time the gas quantity reduced. But during rainy season it was found that there is some bubbling taking place around the wellhead from here in this area. And it intensified, and within days it was observed as a lot of sand has been thrown out from that cellar area. So there was a surface broaching taking place. Keeping that in mind, the well was diverted, 2 diverter lines were put. So in the desert and it was flowing gas continuously. ONGC team went there. They went with C2 inside and tried to control the well, but by that time they're trying. I think one incident happened because this area is very near to the Pakistan border. So at that time, they were not allowed to work for more days, so it got to be controlled, and the gas was blowing continuously. It was diverted. I was being contacted that yes, can we control this well? It was before the Bhagavad. So I went there and saw, and after seeing this condition there, it was not possible to shut the well. Otherwise, there will be a big crater and problem will be there because the ND9, Dandewala 9 well, we have seen in the previously. So as Hirak Datta was telling that yes, you should learn from the mistakes. So we have seen that it has happened in that area like that. So we will not pump directly. We will go with the CTO again. And the plan, there were two plans made in this area. When I visited, number one plan was first, we will try to do surface intervention with the CTU, and number two plan was we will drill a relief well and try to subdue the well at the bottom where the perforations are there. So two plans made and execution was done for these two plans. The rig was placed and the challenge was that if you are drilling that area is already charged, and friends, I think one information I can give it to you. In this well, the casing was parted at 65 meter and the tubing was snapped and the top of the tubing was at 22 meters only. So the gas which was coming from the bottom was from 65 meter, it is pushing to, and there was a bright chance that the surface might have been charged. So when you are drilling relief well, if the surface is charged, it can play havoc in this rig also where the drilling is taking place. So carefully those areas were examined, visited, and decision was taken that we'll drill a pilot, and to ensure that if there is a gas can be handled properly, we will not drill a bigger hole there. We drill a pilot from 8.5 inch to 150 meter, and we ensure that there is no broaching has, because of this parting of the casing, no charging has taken place. Simultaneously, it was planned to do a CTU operation in this based on the discussion with the ONGC crisis management team, which were here in this area. So we started lowering the CTU, but CTU was not going beyond the master. And it was very, very, unexpected problem. We never thought, because the previous attempt the CTU went up to 700 meters. Why it is not going beyond 1.5 meter? We tried with the different pressures, but no advantage. Finally, we decided that let's open the master valve. But this, you see, the master valve is there. So this was opened and we found there's a thick layer of salt and some of the formations which have deposited around the well. And the opening, which was about 2 inches, has come down to 1.25 inch only. And when we saw the side outlet valve, so the opening which was 2 inches, it has become hardly ½ inch, not even ½ inch. My finger was not going in. So it was not even a ½ inch, it's less than ½ inch. So this was the situation which we have, as per our plan, we thought this will be open, we'll go with the CTU and by CTU. But now it has not allowed the CTU to work. What we did, we opened this master valve and saw what kind of pressures are there. Now you see what kind of pressures are there in the well. It's going up about 50-60 meter. So this is the flow which was coming up. So this has given an indication there's a lot of pressure in the well. It's about 100 kg. Pressure is already there in the well. So there's no question of shutting in the well. So first we have to reduce the surface pressure, and then only we can take some action. So in keeping that in mind, the plan was changed. So why I'm telling that the action plans which you are making is not necessary you will execute that plan. When you start executing that plan, as per the informations which you are getting from the well, you have to change your plan. So I normally used to say one thing most of the time when I was talking to my people when I was in ONGC, talk to the well. When you talk to your well, the well will tell you that yes, what the well needs. So we did the talking to the well, and after seeing that, we examined each and everything, and after that we came to a conclusion that definitely we should try a volumetric method in this well. So with the volumetric method, we bring down the pressure below 50 kg, and after that the bullheading was done and the well was killed. So the well which we were trying, the relief well which we are trying to drill, now we are not drilling this relief well. Only we have already done the surface intervention. The plug was placed at the bottom, plug was placed in the middle of about 700 meter, and the plug is placed at the surface. So well has been happened. So why I'm explaining this example is, friends, when we handle any disaster, so time is a very important factor here. If the action could have been taken in the beginning, I think this rig would not have been in place. Would have done it with the CT unit and some tanks, and this kind of deposition would not have taken place. So the time action taken in time can save you a lot of problems. And when you start executing the plan based on the informations received or based on the problems you face, you have to change your plan. So don't think that whatever plan has been made can be executed there. No, it will not happen. So these are the challenges we face when we are handling the disasters. So I have given two recent examples to you. And coordination with the regulating agency is another challenge because they will be coming with a lot of manuals that these are the guidelines. You have not followed this, and all these things. So you have to see that how these regulating agencies can be told that yes, we have followed this, and how we have followed that. So this is another challenge which we all have to face. And regulating agencies, who are the regulating agencies? State agencies. The Pollution Control Board will come, and nearby DM will come. And in this case, when the BSF people used to come in this area, they used to say, I'll explain in Hindi, sir, वो रात को पूरा भाई भाई होता रहता है, 5 किलोमीटर तक इसका आवाज आता है, पिछले 1 साल से हम सुन रहे हैं, इसका कुछ करना है पड़ेगा. So like that, if you management listen that, and definitely, and it is very near to the Pakistan border, so definitely the area was vulnerable. So the action were needed and the fast actions were needed. So how to coordinate with to come? Somebody's
sorry to interrupt you, but due to time constraint, I humbly request you to conclude.
I'll finish in another maybe another five minutes.
Okay.
So these are the regulatory agencies to whom you have to coordinate. Central agencies, environment and nearby villages. Definitely here also the people were coming that raat ko hum so nahi paate hain, a lot of sound is coming. So this is another thing. So why disaster management plan is required? If you don't want this kind of things should happen in the oil and gas industry, let us see that we make a good disaster management plan. Now, major tool for strengthening response competency. This is my last slide. Now, if you want that your response should be better, good, and can handle the disaster properly, the number one thing is the regular training, which is very important. Here, I'll give an example that when this is started, the IWCF training, International Control Forum training, well control training, the disaster rate has reduced drastically and it has come down to about 30% from 100%. Practical exposure and drills, wherever these kind of things are happening, please expose your people to that. And as Hirak was telling, the drills are also very, very important. Whenever you are doing a drill should be done judiciously. वो नहीं होना चाहिए कि आज ड्रिल होने वाला है और आप इंफॉर्मेशन देंगे आज ड्रिल होना. No one should be informed. Only 2 or 3 persons who are involved in the drill should know that the drill is going to take place. Other people should not be informed. Then only you come to know that yes, what are the improvement needed for your disaster management. Another communication skill is a very, very important thing. How you communicate the problems and how you communicate to the people who are working. Is teamwork. Mr. Hirak has already talked about that. And physical fitness is another important thing. Because when you are handling this kind of disasters, you have to run here and there, and you have to be physically fit and mentally fit. Because when a blow takes place, many people they are afraid to go to the near to the well. If you see the recent incident when I opened the valve, people are not reluctant to go near to the well. So no, we will not go because it's a gas coming out, and if it catches fire. When you have already fire tenders available, things available, so I think we should not be afraid of, and we should have courage to handle this. And the last one thing I would like to tell that if somebody else coming from outside and handling the disaster for us, why we cannot do it? I think ONGC has got a good team available, and oil and gas industry should build their own team to handle this. And there's nothing which is impossible. Everything can be done. Only thing you have to do it very safely and keeping the things which I have discussed in mind. You can definitely handle the situation very, very safely without any injury. If you see, I'm with my team and telling them what is to be done and how it is to be done. And I can proudly say that in my career, I handled before the retirement about 32 blowouts, and nobody has got even a scratch on their. So this is how the work was done in the field. With this, friends, thank you very much, and I thank NIDM to giving me this opportunity to discuss or to share my ideas, and I hope this will definitely help people working in oil and gas industry. Thank you very much.
Thank you very much, sir, for your wonderful presentation, providing insight on the challenges that we have to deal with due to disaster and various phases of response, and what should be the strategies to enhance the resilience, competency, and structure of typical incident management plan. Disaster management is a multi-dimensional, multi-level, and multi-stakeholder issue. Hence, it requires horizontal as well as vertical linkage of different agencies. Sir, as of now, there is no question raised by any participant. If there will be any question, I will be sharing with you. And thanks for sharing your valuable time and sharing your experience with us. Thank you very much, sir. Now, moving to our last presentation, I invite Sri Anand Ray. He is Chief General Manager, Head Training, IPSAM ONGC Goa. And sir will be sharing the interventions and initiatives that are taken by ONGC for inclusion of disaster management training to strengthening its resilience against catastrophic events. Over to you, sir. Ray, sir, are you there?
Hello.
Hello. Yes, sir.
Unmute. Yeah. Yeah. Are you getting me now?
Yes, sir. Yes,
Am I
sir.
audible?
Yes, sir, you are audible.
Okay. So my presentation is getting. Just a moment. It is just uploading my little time. Yes. Is my presentation visible now?
Not yet, sir. Not yet, sir.
Not yet. It has opened at my end.
Yes, sir. Now it's visible.
Just a minute. Okay. So, respected VP former director, ONGC, Sri Hidek Datta Sahab, ED, ex-ED, OSD, my senior colleagues, ladies and gentlemen. First of all, I welcome you all to this training program and very happy New Year to all of you. I thank NIDM management and ONGC for giving me this opportunity to share my experiences with you and some of the views that our management is going to have over the inclusion of trainings to the disaster risk reduction and resilience. So, as we have seen that earlier lectures also, that the Disaster Management Act 2005 has led to a paradigm shift in its approach towards the handling of disasters. Basically, earlier approach prior to 2005 was for the relief-centric approach, whereas the 2005 has given a proactive design. It has opened a new design which is very proactive with respect to both response, relief, and in all those stages. A total shift is there, which is emphasizing over proactive methods to be incorporated for the control of risks. And it is holistic and integrated approach, building strategic partnership at various levels, starting from the block level to the top level, central, state, district, and block. So it encompasses all the levels, including different sort of partnership, and which is holistic in approach and which is proactive. And the emphasis has been laid on preparedness and capacity development. So preparedness and capacity development has been giving a lot of emphasis in 2005 version of this act. Consolidation of past initiatives and best practices, identification, assessment, and monitoring of disaster risk. So monitoring and risk assessment has become the foundation stone or building blocks for both at the mitigation level and preparedness level. So this is really a very good initiative in this act. And finally, to build disaster resilience structures and for ensuring safer living is a part of mitigation, you can see. So there has been a thorough change in the approach towards encountering and handling disasters in this 2005 Disaster Management Act. So as you can see, the disaster management, it starts with mitigation, preparedness, and suppose the disaster takes place. After that, it talks about how to handle, have a good response system in place, then recovery, and based on the recovery, further development. So the cycle is ongoing like this, starting with mitigation. Mitigation, measures that prevent or reduce the impact of disaster. It can be both the way through which it can be prevented or reduced. Preparedness, it talks of planning, training, and educational activities for things that can be mitigated. Response, the immediate aftermath of a disaster when business is not as usual. Recovery, as you can see here, the long-term aftermath of a disaster when restoration efforts are in addition to the regular services. So this is a complete cycle in which you can see the preparedness part. We have elements like planning, training, and educational activities. So the primary goal of any disaster management plan is, the primary goal of the emergency response is to protect the health and safety of the emergency responders, public, private, the environment and minimize the disruption of community activities. This is the primary goal for any disaster management plan and disaster risk reduction and resilience activities. The resources of the community include trained personnel and emergency relevant facilities, equipment and material. Is the best thought of as a process. When we think of preparedness, as our directors of Mahawar was explaining, so it talks, basically it is a process. In one piece we can't see it. It has number of interfaces with different activities. So it's a process, a continuing sequence of analysis. Based on those analysis, development of a plan, that is the preparedness plan we have to make depending on the type of disaster that has taken place. We analyze it, sequence of analysis. Then based on that, plan is development. We have to plan our development plan. Preparedness plan is need to be developed. Then acquisition of individual and team performance. And finally, the most important thing, as you can see here, the skills achieved through training, drills, exercise, and tricks. So this is a process depending on the activities as mentioned here, and each element of these activities is interrelated. So we have to have a totality, a holistic approach. Only then any stage of this process of disaster management cycle can be achieved. If we are lacking on the front of training, drills and exercise, we can't be successful even if we have plans available, because ultimately we will not be able to respond in the way we are supposed to do unless and until we don't carry out drills. The skills of the regular exercise, and of course we should have critics, that is observers, who will point out how can we further improve our drills or exercises, what the shortcomings were there in the drills or our exercises. So then it's a cycle. Then for again the performance of the individual team, individual people has to be taken care. What were the shortcomings? How can we further improve it? And depending on that, we have to improvise our preparedness for the plans. So it's a cycle. That is analysis. Then based on that analysis, develop the plan and all these steps. Now, talking specific to the ONGC operations, as you have seen earlier also explained Mahawar, the different risks that are prevailing in the organization as far as the disasters are concerned. The hazards basically start with its very nature of operation in ONGC. Hydrocarbon itself is hazardous, as everybody knows, highly inflammable. It affects the environment. It can lead to that fatalities, fire, explosion, so many things. So hydrocarbon itself in the very first place is very hazardous in nature. Then our people are working in offshore also, and offshore, both operations are there. So marine environment is a challenge in itself, and it poses a number of risks, associated risks with hazard. Toxic gases, our people are working in a very toxic environment like hydrogen sulfide gas. This is a common thing with the production of oil and gas. Number of fields are there where we face these challenges. Then air operations are there. People are flying by choppers, and it poses a number of hazards and associated risks involved with this helicopter operations. The ground logistics, we face number of accidents sometimes. Heavy load handling, weather, it's a challenge. Working in extremities, sometimes very hot temperature, people are working in the open. They are exposed to dehydration, sun exposure. So such kind of things are there. Even in very cold countries, our people are working. So those challenges. Then we have pressures, and you are seeing pressure in a big way, how blowout were controlled and how it was posing a big challenge. In the previous lecture you have seen. Working on height, yes, our people have to work on height. When the drilling rigs and work operates, they go to the top, and even the construction activities are going on. So this another, and finally the hazards related to the people. So people at large, that is people not only own employees, but the people who are in the neighborhood of our installations or working station. So these people are also exposed to different number of hazards. So the risks are associated with normal population residing alongside the working station or workplace of ONGC. So these are certain areas of major risk. There are other have just complied some of the major risks here. What are the control measures in place in our organization? You know, ONGC is a high risk and high technology industry, and I've already mentioned that we are dealing with a very hazardous material. So accordingly, our management is prepared to handle this scenario. For this, we have a structured approach for the management of emergency and disasters. Like we have documented plans that is called emergency plan and disaster plan. At each level of operation, like starting from our unit, basic unit, that installation level, you can see we have site-specific emergency response plan. Then we have regional contingency plan at regional level, and then we have corporate disaster management plan. We call short in CDP. So we have ERP, we have DMP, or we call it RCP in offshore. We call it RCP. Then we have CDMP. So three structures are there. A point to be noted here is that, as you must have noticed by now, that in case of any disaster or in case of a major emergency, he should take any action on his own thought or on his own perception, because it leads to a lot of disasters, further disaster or accidents. The steps that are required to be taken has to be well documented, and a person who is there, he has to follow in totality those guidelines. If any deviation is there, he approved a prior permission for any competent authority for any deviation. ERP, emergency response plan, which is developed and which is developed with the help of a multidisciplinary team, depending on different scenarios, potential risks involved at that place, and then it is developed based on the experience of the people need to be followed. Similarly, three-layered structure is there, I have discussed, so that is there. Then Government of India constituted Offshore Security Coordination Committee headed by DG Coast Guard in order to take into control the different disaster scenarios in the offshore. Regional Contingency Committee comprising of Indian Navy, Coast Guard, Indian Air Force, and other central and state government agency is there for RCP, Regional Contingency Plan, and its execution. And then we have dedicated crisis management team. I want to share with all of you that in ONGC, we have one of the best, I should say, crisis management team, because this has been established during the course of time that ONGC has not only catered to the need of ONGC requirement, but in case of major blowouts and major emergencies occurring during the oil operation, our crisis management team have helped other Indian company also, Oil India Limited or other places also. They have gone and they have controlled, and the professional level is of very, very high magnitude. They can handle any kind of, we are not, I should say, inferior in any way to any one of the best international agency you can name. So the competency of the CMT in ONGC is par excellence. So this is the way our organization ONGC is handling different kind of disasters scenarios, and we are prepared for this. Now, as you can see, we have a structure here. And in the top, this is National Crisis Management Committee on the top. For NDMA, National Disaster Management Authority is there, as per this 2005 Act is there. Then according to the top bodies, Government of India, NCMC, then before them, the crisis management plans are made under that. Then we have corporate DMP, and here only this this core team, the core team is there at the government level. NCMC is the top, then CMP is there. Then we have corporate DMP in ONGC, corporate disaster management plan, regional contingency plan, emergency response plan. So the layers you can see starting from the bottom, the second level, the third level, the fourth level, and the final level. So on the top, you can see these are the stage one. The strategy is decided at this level, and then the execution is start down the level. elaborated again. Installation specific emergency resource plan. We call it level 1. Emergency situation which is controllable with the help of resources available at site and where only site and personnel are involved. Level 2, we call it DMP, that is asset level, on-site disaster management plan. Emergency which can be controlled with resources available with asset. Then when the magnitude of the emergency or disaster escalates beyond a certain limit, and at asset level we are having problem in controlling that, we have DMP, corporate DMP, that is level 3A, emergency when intervention at corporate and national level is required, and off-site DMP, emergency which required mobilization of resources through local administration, mutual aid agency, state, central government. So government interference when it is required at a higher level, then we call for the off-site DMP. Now, before you can see, we have a mechanism in place to control the disaster at most at the corporate DMP level. We are capable of doing it. Sometimes it happens that we are not able to control it, then we have to go for to control it, then with higher level intervention. Similar to this, we have oil spill management system also, because as you know, the hydrocarbon has both the thing in the liquid form also as far as the risk is concerned and safety is concerned, and when it burns in the gaseous form also in the form of heat and gases, it poses another. So blowout as well as oil spill, both are big challenges associated with our operation. So in order to have a system that in case a disaster occurs because of the huge oil spill, our company is thoroughly prepared for this. We have oil spill management capability for spills up to 700 metric ton. As for IMO, oil spills are categorized in 3 levels: IMO level 1, 2, and 3. The IMO level 1 is up to a spill of magnitude up to 700 metric ton is IMO level 1. So we have our own capacity to control such kind of disaster. That is that we have a disaster management plan, oil spill response plan, what we call, in place. Then we have tier 2 spills envisioned with Indian Coast Guard and National Oil Spill Disaster Contingency Plan, NOS DCP, what we call. So with the help of Indian Coast Guard, totally prepared to control any level 2 type of spill, that is a spill up to 10,000 MT, 10,000 metric ton oil spill when is there, we can control it. And then we have MOU with other operators for pooling of resources at both the ends, and agreement with OSRL, Oil Spills Response Limited, UK, for larger tier 3 spills, that is more than 10,000 ton oil spill are there, then we can control it. We have a tie-up with OSRL UK and active participation in annual NAT race under the chairmanship of DG Indian Coast Guard. Regular drills are carried out. Yearly drills are carried out so that we measure our performance in case of any oil spill disaster that at all it takes place. Our organization is well prepared with the help of such kind of mechanism in place. Now, coming to the core of the thing that my topic is defined to is the training on disaster management in ONGC. What kind of training ONGC is providing? Now, we are conducting number of training programs. Some of them are listed here. One is the blowout contingency. In Narsapur, in ONGC, we have a complete facility where a blowout is artificially created in a controlled manner, and how to fight it. A practical live training is given to the people. So that kind of training facility is available within the organization to prepare our manpower to fight such kind of contingencies. Then we have disaster management for business and community management team, BCMT members. Another training program is there. Then training on oil spill response preparedness, IMO level 1 by Coast Guard Mumbai. We have a facility in place. Then we have training on oil spill response preparedness, IMO level 2 and 3 by Oil Spill Response Limited UK. So these all kinds of trainings are being provided by ONGC to its personnel in order to create, as you have seen in Disaster Management Act 2005, there has a lot of emphasis has been given on capacity building, and training is pillars for making for developing capacity building among the people. So in view of our organization have taken such kind of steps to empower and enrich the knowledge and skills of our manpower to fight such kind of scenarios. Now, what can further be done? So, what planning in days to come, that we want to introduce training programs with the help of NIDM, training on site specific emergency response plan. So this is one area. Then we can have training on off-site DMP, training on corporate DMP. Such kind of training programs are not there right now in our curriculum within ONGC. So we can design with the help of the expertise of NIDM together. Then we have another area, point number 4, training on onshore spill preparedness and disaster management, training on offshore spill preparedness, disarmament IMO level 1, 2, and 3. Right? As you can see that for the training IMO level 2 and 3, we are approaching outside agency. Like we are approaching OSRL, Oil Spill Response Limited UK. They are providing us training. So with the intention of Atmanirbhar Bharat, with the help of NIDM, we can go for designing training programs at the level of these international programs, so that we can have in-house capability for providing such kind of training programs to our own people. Then we can have fire disaster in high-rise building. So this training program, these are certain areas starting from point number 1 to point number 6, which can be taken up together with the help of NIDM, and we can develop training programs to further strengthen our manpower and capacity building. Methodology for development of the training modules can be something like the course content of the training modules depending on the emergency scenarios of the NP industry with reference to points discussed earlier. Develop the course content, course material, and standardize our PowerPoint presentations. Identification of domain experts, faculty for the training programs. Conduct a pilot training program, analyze the feedbacks. Depending on the feedback, modify the training program if required. If the 95% of the feedback rating is excellent, the training will be validated. Similar trainings will be conducted at pan-India level. So this is the proposed plan which we are looking forward with NIDM to come out with, and this is the strategy through which we design and develop training program at our esteemed institute, IPSAM Goa. And the same thing can be followed for development of the new training program or inclusion of the new training program with respect to disaster resistance and resilience. So with this, I thank all the participants for patience hearing, and I thank once again all the coordinators of this training program for giving me this opportunity to present my knowledge and share my experiences with all of you. Thank you very much.
Thank you very much, sir. Thank you very much for providing glimpse of Disaster Management Act 2005, basic elements of disaster management cycle, and beside strategies of ONGC for TRR, including emergency and DM plans, their coordination committees, as well as dedicated crisis management team to handle any kind of unpleasant event in the sector, and roadmap of ONGC for future disaster management training. Thank you very much, sir, for sparing your valuable time and enlightening us on the investment of ONGC in creating a disaster-resilient infrastructure and environment. So with this, we draw the curtain of second day of 3 days online training program on disaster risk reduction in hydrocarbon sector. But before that, I would like to thank our distinguished speakers, Shri Hirak Datta, former ED for IST, Ministry of Petroleum and Natural Gas, Shri VP Mahavar, former Director ONGC, and Shri NN Ray, Chief General Manager, Head Training, IPSAM ONGC Goa, for sparing their precious time and providing us opportunity to learn and gain from their experiences, expertise. So tomorrow, on the last day of the training program, distinguished speakers, namely Dr. R.S. Chimote, Chief Scientist, CBRI Roorkee, and Shri Sanjay Kumar, General Manager Fire Service, IPSAM ONGC Goa, will be gracing the technical session. And same link will be active for tomorrow as well, and it will be activated at 10:30 a.m. And thank you all for joining us. Please take all the precautionary measures for COVID-19. Wear mask, follow physical distancing, and maintain hand hygiene. See you all tomorrow.